if you're just getting in, this is, if you hit that repo, that'll give you setup instructions. We are actually going to match keys today, so like, yeah, we don't have to. You can, okay, it's a choose your own adventure. You can just sit and watch, or you can actually type this out. It's an either or. All right, should we? Yeah. So if you're just getting in and getting started, definitely hit this repo query-io/ipfs_camp. If you go here, you can get our latest release of our binary and install it, and make sure you can do this. Type query and see some output. If you can get to that point, if a couple of people could put their hands up when they're at that point, great. If you don't want to play along, it's totally fine. I can just type for you. That's fine too. Who here wants me to just type for them? Okay, yeah, all right. I'll pull you. I'm going to pull you for more stuff as we go. But yeah, let's see, what time is it? It's 12. I guess we can kind of get started. Cool. Thanks so much for coming, everybody. Yeah, so I'm going to talk, and we'll sort of go through this, but definitely, I think I definitely was a big fan of the like learn Python the hard way, where like you type everything many times and it sort of goes into your head a little better as you're like doing that. So today, if you have any interest in doing that, feel free to do it with me. But otherwise, thank you for coming to a session on Query, which is the project that I work on. Let's make this, sure, let's have a presentation. So this is Elective Course G. Hopefully you're in the right room. If you're not, we're going to talk about data sets on the DWeb. Today, I thought we would do a bit of a blend. How many people here are like into data science, would call themselves data scientists? We got 2. Amazing. Kind of what I was anticipating, right? We're at a DWeb thing. So today, I'm going to kind of do 2 things. We're going to show you how data science might be helpful, or at least doing data version control might be helpful for you as a developer. And we're going to talk a bunch about how Query uses IPFS, and mainly sort of focus on those things. This is sort of if at any point you are building on top of IPFS and you want to stop me and understand how we're doing something or get more details about something, all of our code is open source. I can link you directly to places in our code base that would be good for reading. Our code is written in Go, for which I'm not going to apologize. Yeah, but I'm into it. So with that, I think we're going to try and quickly blast through sort of like a quick overview of what Query is, but again, taking these detours to get into IPFS. So with that, I'm B5, Brendan on the internet. You'll see me on GitHub as B5. I work on Query. Pronounce Query, spelled QRI. I will apologize for that. Yeah, it seemed like a good idea at the time. At the time, it was like SQL query, kind of like, and it's about questions. That was sort of the vibe. But Query is about data sets at the end of the day. This is about versioning data sets on IPFS. Data sets are kind of our granular model. It's a document that we like to think about. Everything we're going to talk about today is about sharing, versioning, moving data sets around. You can come in. No? Okay. So just to give you like an overview of the mental model, Query is kind of a new thing, but it's also a combination of old things. We see it as these 3 things sort of vend together. It's a version control system, it is a database, and it is a peer-to-peer network, kind of at the same time. Again, thinking about all of this inside of the context of data sets as your document model. So this is like the technical underpinnings. When you're working with Query, you just think about data sets. You don't actually like worry about these things. But yeah, this is a very important technical diagram of how Query works. We put blobs on top of IPFS, and yes, we'll get into, and we will explore exactly how that relationship is negotiated. But that's all I got. A network on Query kind of looks like this. This is how Query is sort of an overlay network on an overlay network, which is kind of fun, and I think a pattern that you'll see a lot if you're somebody using libp2p. And so if you have any questions around that, Query is a protocol registered as a libp2p multiplex handler, and so we can talk about that too in details. But anyways, with that, if you have installed the Query binary and you're playing along at home, let's, again, just as a quick reminder for anybody coming late, I'm basically going to blast through this. If we can skip stuff, because we have these, I've sort of outlined things, so if we get sidetracked with questions, you can come back here and like finish out the tutorial later. And so if we go over time, I don't know if we'll go over time, but we can sort of go through all of this. But I'm basically going to talk through these 4 sort of steps. And so the first thing we're going to do is just actually do like our hello world of a data set. And so today we're going to do all of this from the command line. We do have a front end, but I think it's fun to like, since we're like, and particularly because we're going to do a lot of interaction between IPFS and query, it's nicer to sort of do this all from the command line. So I'm going to try and make this bigger. Someone yell at me if this is like, is this a good enough size? Or is bigger required? Good. Good? Okay, cool. So if you're playing along at home and you haven't run query setup yet, this is the one thing to run. You will choose this. Obviously, I'm getting an error because I've already set this up. That'll ask you to choose your peer name. That is a human readable name that we register with a centralized registry of names. But this is very similar to your GitHub username, so choose wisely. Anybody make it through query setup? Are we there? Cool. We got some thumbs up. Awesome. So the first thing I'm going to do is just make a fresh directory and cd to it. So I'm going to work from my desktop today. I'm going to make dir workshop because I think I said I would call it workshop. Cool. And then I'm also going to open a text editor. I'm a VS Code person. If you're some sort of code ninja, that's great. Use whatever you like. I'm going to close this out first. Cool. What am I going to do here? I'm going to do this on desktop. Workshop. Cool. Sorry. Workshop into a new fresh thingy. So I have no files on the left. I set my text editor to white, and this is really throwing me off, but it's better to see. And so the first thing I'm going to do is I'm going to go back to that tutorial and just copy and paste this random stuff, and I'm going to call this hello.csv. Cool. So if you've made it that far, we will notice immediately that like this data is like slightly messy. There's an extra comma here, and that's on purpose. So copy and paste that too. And we'll just get to our first command. We're going to do query save file or body, sorry, and basically just type this, and I'll explain this in a second. But is home.csv, and then I'm going to type me/hello. That's not found. Where am I? Demo hands, man. I'm not good at it. Save body. Hello. So the tab is going to be my friend today. So, oh right, I have to reset this. Delete all me. Hello. Cool. Now this is what you should see. When you run this, you've now, if everyone has seen this in the background, this is a dataset version has just been created. So we're seeing some familiar stuff from IPFS land. This should look familiar. I'm going to make this bigger. But under the hood, you'll notice that we've already picked up a validation error. We didn't provide a schema or anything to query. This is just a CSV file. Query has done a bunch of work under the hood to sort of like try and help us make this data interpretable. The whole point is you can put really messy data into query. We think you should be able to start with stuff that's invalid, gross, weird. As long as it'll parse, it should go in. The types of file formats that you can put into query are JSON, CSV, XLSX, I can never say that out loud, and CBOR. So you can feed those in, you can version any of those, you can convert to and from any of those. Some of those conversions are a little funkier than others. High dimensional CBOR to Excel files is not the greatest thing in the world, but it happens. So just to go through some of the other arguments that are here, I gave this an argument called body, and we call the actual data in a data set the body. And so we think about this like an HTML web page, right? So we've got the head, which is all these other components, and we'll get into them in a bit. And then the actual data is called the body. Just to help us distinguish, because like we're going to be writing a bunch of stuff. But everything else in a data set is about the body. The body is the principal subject. Generally, if you're thinking in tabular data, most data science occurs in tabular data, but query totally supports high dimensional data, lots of GeoJSON, lots of whatever you want to put in there. Definitely just structured data. That is the body. Cool. The thing after that, the me/hello, is the dataset name. And so this is, me is a special keyword for whatever my peer name is. And so if I type me, I'm always referring, I think my peer name is foo. And so that means, yeah, I created foo/hello. And if I do query, just to like confirm this exists, I can do query log me/hello. And I see a log that, hey, cool, I made a data set. This should feel similar to Git, but who here has worked with Git? Awesome. Good to know your audience. Let's cut to the chase. Query has some differences. No staging area, no branches, and everything is. And we have a very different notion of a repository, and we'll get into that in a bit. But the thing to keep in mind here is when I hit save, that went directly from hello CSV. It is now versioned and stored. I can blow away that CSV file. It's stored inside of IPFS in this hash. We'll get into that in a bit. But the next thing I'm going to do is, because I can blow away that file, I'm going to just take out that error and add green here, save that file again, and I'm just going to run the exact same command. Query save hello, me hello. And this time the dataset error is gone. And if I do query log, the right way, we see that we now have a thing. Other difference from Git, dataset commit messages are optional. We generate for you automatically a sort of textual description of the dataset. Currently there's a bug that makes it kind of look like GAC in this presentation, but it's valid stuff. And we actually sort of just take a look at what changed inside of your dataset and give you a Git description, or a commit description. You can absolutely override this, and when you're doing very meticulous work where you want to be leaving a very real audit trail, you want to override those messages, right? You want to set titles and you want to leave a trail of how you did the things that you're doing. But there are situations where you can actually automate the updating of data sets we'll get into later. And so having these automatic commit message generation means that we don't have to put a human into that loop if we don't need to. So that's kind of a good start. We now know that the body, we can just quickly explore, like I'm going to preview one other thing. We have query get, which is our way of sort of getting pieces of a data set. If I just do me hello, this is going to show you that there's actually a lot more going on under the hood when you give us that CSV file. We inferred a schema, and we picked up that there was a header row. We figured out that the format was CSV. We figured out how many entries were in it. We calculated a checksum for you. We figured out the depth of the graph of your data, so we know that it's a two-dimensional array. We know the length of it in bytes. We tried to infer that the number is an integer type because there were no floating point values in it. We also inferred a basic visualization script for you and added that into IPFS. And all of this has been intelligently versioned so that as you change different components of this data set, we'll get into some of these components. This is the structure component, which is created for you. There's always a commit component, which is the actual versioning information. All of that is being stored separately inside of your IPFS repo, and we've been very careful about the way that that's arranged. So as you're creating new versions, your body data isn't duplicating if you're not changing your body. And so if we're thinking about the Merkle-DAG graph that's being created by this, if we don't change the body blocks, we're constantly just making new commits that are referencing that same data. And so we have a really nice deduplication factor across all of our versions. If we do change data, then we get new blocks. Anyways, yeah, so just to sort of like round this out, I can do query list, and I can now see that I have data sets that I should have deleted before, but I have foo hello in there, which is good. Cool. So everybody so far, do we follow? Any questions on that section? This is just like super basic. This is how we create data sets. This is basically, at this point, we have cleaned a data set, quote unquote. We've removed one validation error. But that's sort of as far as I think we need to go in terms of the actual like manual data set creation for today. Questions?
So you're not collaborating. So I'm running IPFS elsewhere and query. So query
Yes.
runs its own version of IPFS. So
Yes.
you can't run them both simultaneously.
Yes.
You're not collaborating my IPFS repo.
Oh, we're totally clobbering your IPFS repo. So I put a note at the beginning of this saying, before we begin, turn off any running copies of IPFS. And this, I should have said this out loud. But I can help you unmess up. But we can actually, the next chapter is all about what query is doing to your IPFS repo, so we can see explicitly what's happening. So this is where things actually get like modestly interesting. And so for this section, I'm just going to punch in here. I'm going to type query connect. Query connect is our IPFS daemon. We like the word connect more. Deal with it. But we'll notice right off the bat, something that I think is fun to like look at. We have this, oh, it happened too fast. Okay, well, that was going to be fun to demo. But I'm going to open the web app, which is, if we can see here, it is being hosted at localhost 2505. If I hit 2505 and hit enter, this is our GUI. And so we ship this over IPFS. Under the hood, we have an IPNS DNS record that is constantly updated, and query checks that every time it starts. And if it sees a new hash, it goes and tries to grab that, and it pulls it off the DWeb and pins it. And so that's what we were seeing Here it says, hey, fetching web app file with distributed web. When you first boot query, it will actually just like put you into this loading screen, like, hey, we're trying to find your app, just give us a second. And like, once it gets it one time, then it'll always be able to revert to at least one version of the web app, and it'll continually sort of hop itself to the next version as it comes up. So it'll unpin the previous one and pin the latest, and just keep your web app up to date for you. And I think this is like a good point to start explaining my very technical graph of query blob on top of IPFS repo. What's happening is we have a copy of Go IPFS 0.4.21 under the hood, imported as a dependency into the query binary. And so that's why we're competing for the repo lock. If you're running IPFS daemon and something else, query can't take possession of that lock. Query also respects everything about IPFS daemon or IPFS, Go IPFS as is. So all your Go IPFS configuration, that all is in there. If you set IPFS path, the environment variable, all of that is respected by query. And so the goal is just to have, what query is really doing is just sort of puppeteering your repo into doing the things that it thinks are special and valuable. And so when we were doing query save, that was creating a data set, pinning it for you, and keeping that root hash locally. When I do query delete all, that unpins everything. It doesn't run garbage collection for you. That should be noted for anybody who wants to clear those blocks up later. But everything about a data set is stored inside of IPFS. They are completely self-contained things. So like a data set actually functions completely out of band from query itself. Like the actual data result is something that you can look at raw in the gateways. And we'll get into that in a second. But while Query Connect is running, I'm going to open another terminal and just show some of the we have some built-in sort of things that allow us to inspect query peers as well, which I think is valuable for this crowd. So if I do query peers list, I see a different thing from normal. So we made the decision to overlay a second profile identity on top of your peer ID. The reason for this is if I wanted to move my profile around or have different multiple IPFS repositories, I'm able to do that. And so now I have, my actual peer name is associated with a profile ID that is separate from my key pair for our IPFS repo. We use your profile ID to sign commits. So every single commit that you make is signed with that key pair, and that is stored with IPFS, with queries separately. And so every single commit is attributed to a person, and that is part of your audit log. And nobody, obviously, thanks to cryptography, it's unless you do something stupid with that key pair or the private side of that key pair, nobody can make commits that look like you on query. And so this is very similar to Git. It gets verified commits. That's just where we start by default. All commits are always verified in query. So I can list my query peers. I can also list my IPFS peers by doing network IPFS, and I see a very different number, right? I'm now on 95 at this point. For debug reasons, a long way back, we listed what was in the connection manager, and we should probably take that out, but it's in there. We also, actually, here's a good example of what we do when we find peers who support query. We talk to the connection manager and we say, hey, this peer supports query, and we add this number that is a little arbitrary right now, but it's 100, and that basically says, hey, please hang on to that connection for as long as possible. And in our experience, that has gotten better and better over time. Thanks, Go IPFS team. Yeah, so at that point, I think this is kind of like sort of what's happening under the hood. As you can see, like there are queries sort of like layering a couple of techniques on top of IPFS, but we're also, whenever possible, dropping into regular IPFS communication. We also have but we have some niceties that sort of come up here. I can do query peers, let's do list first. Sure, blue. Peers connect blue. I can just give the name of a peer and it'll automatically dive into query, pull out from the address, do the linking to the address book, find out what that latest seen profile ID is, and try to make a connection to them. Works sometimes, doesn't work all the time. It really depends on how recently you've seen that peer, because we're actually persisting some of that data. And as we know, that changes a lot. But if it can figure out a way to connect, you can just give it peer names and connect in. But you can also just pass in a classic multi-address here to, you could do like IP4, blah, blah, and that will also just delegate that down into Go IPFS for connections. We can also, while query is running, because Go IPFS's HTTP API is exposed, we can do all of our usual IPFS commands. So IPFS --API IP4 127.0.0.1/TCP/5001 by default, bitswap stat. Oh, of course I did. Thank you. Yeah. So you can still talk to your API. We also surface everything from your normal, we try to Johnny, to your point, make it as like seamless as possible. When we do have the lock, we don't want to be a bad citizen of of the IPFS ecosystem. So we still run the web UI. Everything about your gateway is still running under the hood. You can configure pub/sub and pass that down. There's like 2 arguments that are special to the Go IPFS daemon command line. You can set that in query configuration, so that'll get passed down. We have some folks who are using pub/sub to listen to when query datasets are created and then orchestrate who replicates those pins. They're well out ahead of us. They're doing airplane monitoring. It's fun stuff. But yeah, cool. So that's kind of, any questions on that, on how that interaction works? I mean, I think this is probably the part where this crowd might be the more interested in this stuff. Anything?
Yeah, basically the question is like how, like, can I use it like standard API style, or like what are possible problems with like very different node?
Right.
They contract with each other.
Right. So the goal is to have this be as standard as humanly possible. And so we're keeping this, obviously we had to punch in this API thing. I'm working on that. I think we can get around that bit too. But it should behave exactly the same as Go IPFS. Any deviation from that, in our eyes, is a bug. But obviously we have these other overlays on top.
For example, Radical has also like the node on top of IPFS.
Mm-hmm.
If I want to run it, how can I do it?
How can I do both? Yeah.
Together?
And so this is currently a bit of a limitation of our design, like IPFS daemon and Query Connect kind of conflict with each other because they try to possess the repo lock.
So no way right now.
No,
So
but
maybe it's the light version.
Yes.
There's Go IPFS Lite.
and I think there's a number of ways we can also start programming around. Like the nice thing about the working Core API is we will be able to just take the HTTP API version of Core API and talk to that. Right now, the only limitation is like we actually register a stream handler with the host, which isn't exposed to us over the Core API, and so we need to be careful about the way we do that. But I think long term, it's doable. We'll just have to figure out a solution for that. Does that make sense? Cool. Awesome. We're just blazing through this. Let's move on to lesson 3. Which, what are we doing in lesson 3? Oh, we're actually going to get stuff. Cool. So I thought it would be fun to like actually look at some data that is, so this is different. I'm gonna kill Query Connect on the left. And in this case, I'm just gonna punch in, oh yeah, let's do this first. So another thing is different. We're trying to run a service that is visible to both internets. So when you publish, this is app.query.io/v5/libp2p node count hourly. This is what you can see. There's no software here. This is a website or web page. This is our React front end, but running in read-only mode. And so we aggressively tried to get you to download the existing app. But this allows other people to sort of see this, see the data that you're publishing, including our plan for this sort of in the next quarter is to land this is a React app. We're going to render this server side and put in everything for Google dataset search. So you will actually just, as you publish query, you will show up in Google's dataset search, which we think is a very important sort of cross-compatibility thing. We've intentionally sort of biased towards the distributed web. The point here is to surface information to folks who don't know anything about the web distribution, but you'll notice that on the web app side of things, I have to be running Query Connect for this, sorry. On the web app side of things, we have a visualization. We also have body data, so I can actually see the actual body information here. And this is fine to get because I'm grabbing this information from my local IPFS node, right? This is information I'm operating on locally, or I'm operating off of the distributed web. There's no load being placed on some centralized service here. But what Query does is to be able to actually surface this information, when you run query publish, you are publishing to our pinning service, which is pinning this data set for you, and all we are keeping is the raw sort of blocks for you, which means that it's also available on the gateways because I can turn off Query Connect right now and do ipfs.io/this thing, and we're going to see something different. Awesome. And so Query also includes a component called visualization. And so visualization allows us to give HTML documents that template in anything from the data set you want. And so in this case, we're templating in the node count. And the HTTP gateways are smart enough to see a file in UnixFS v1 called index.html. And we thought, well, hell, if we have visualizations and we have data, why don't we just show you the visualization right on the thing? So we're looking at a raw IPFS hash, right? Under the hood, we have body.json. the data's there. Look at it. Oh my God. Yeah, we'll get into that in a minute. But we can also sort of present this viz, which I think is really an important point to get at. Every single query data set is a document. This is not a history. We're looking at a single version of something at a single point in time. It is completely self-contained, and it's giving us this like thing that we can show to HR or whatever, right? It's something that is sort of more palatable. But this is a completely self-contained auditable data set. All the ingredients you need to understand this data set are in that Merkle DAG. And we've carefully arranged it so that every single query data set is set up the exact same way, which means that every single query data set can be interpreted the same way. If I can convert the body of any query data set to JSON because it's always going in the exact same way. I can compare bodies from any 2 query data sets because they're always the same way. I can extract the meta.title from everything because query will only let you put metadata in the meta section, right? So we're very strict document model at the top level, very loose document model for the actual data set. And so this is just like high charts, like basic HTML, but this is actually the most recent node count, which is this undulating pattern of the total number of nodes is like an interesting thing. And so we'll get into that. To get into this, why don't we get this data set? So I can like go in here and then say, hey, this is something I want. I'm just gonna copy paste the end of this. I'm gonna turn, so IPFS Connect, or Query Connect is off. Oh my God, I confuse this all the time. I'm gonna type query add, I'm gonna punch this in. So my node is not on right now, right? So what happened is, because I'm not connected, we're thinking about data scientists, right? We're not thinking about like puritanism of like where you're fetching from. So because you weren't connected at that time, it just said, hey, we're gonna go get this from the registry. And so that desync thing that we just demonstrated yesterday is how we did the pull from the HTTP query gateway. That fetched 20 blocks and synced that locally. When that conversation happened, we sent, just said, hey, we want this. And because we knew nothing about it, it sent everything to us. If we were smarter about it, or we sent it CID, we would actually generate a manifest and send that back. And it would only send us back the blocks that we needed. But now I have this locally, so I can do query ls, and I have all of this data locally. And if I do query connect and load this up on my machine now, on localhost, what did we do? Did we daily or hourly? This one, cool. I can now actually get at the body data, right? And I think this is the thing that we really want to push people towards, is like, if we use the distributed techniques, this entire exchange is like fine, right? Like, this is free to use because it's the distributed web. So the cost of moving this around, why aren't you loading? Come on. Demo gods, come on. There we go. Twice as nice. And I think this is really important to sort of like surface, like in this visualization, we have one chart of the total number of nodes. And this is just such a common occurrence in data science. Like, look at all of this data under the hood. Like, we have this set of metrics is breaking out every single registered version of that is on the network. So this is every node version that we're seeing. And so and we have timestamps. Like, this data is far more interesting than what is being shown in that single graph visualization that you were seeing. And so it's also very important to note that when we ran query add, we only got a single version of that data set. We did not fetch the entire history. This is different from Git, right? Git, you do Git clone. What's the flag for clone only, the most recent? Thank you, clone shallow. Nailed it. This is effectively Git clone shallow. Features that will be coming forth in the next little while are some way to see the stuff that you don't have. Currently, we don't have that in, but yeah. So with this data, like, we can now sort of pop over to, I'm going to turn this off again because I'm constantly turning it off and on. But I'm going to do query get, and I'm going to pass it a filter that's going to say, just give me the body this time, because when I do query get me libp2p node count hourly, we were doing daily, right? Daily. What? Hold on. Query ls. That's correct. Oh, yes, because I'm not V5. Query get. Oh my gosh. Cool, let's do hourly, because that's working. So this is actually just showing us the actual sort of head content of a data set. So we're seeing the description and words and stuff. I want to get the body, so I'm going to do query get body. And this time I'm just going to copy paste because I don't want to get that wrong again. Cool, this is actually going to show the body data. Okay, neat. That's not super useful. Let's convert that to CSV and pipe that to hourly.csv. That's not a pipe, but you know what I mean. And then if we look at hourly.csv, we can now open this up in some other program. And what's important here is like people who are doing data science really need a high degree of interoperability. So you can be working, there is a Python package for query that allows you to talk directly to this from Jupyter Notebooks. And so you can be like, okay, cool, give me this data set at this version. And it's just loading as a pandas data frame into your Jupyter Notebook for when you want to do super hardcore data science. But in this example, we want to do some baseline analysis. So I'm just going to like click this column. And if we look down here, we get some like basic analysis. Look, hey, the average number of nodes connected is 96,822. Oh my gosh, that's a high number. And we can sort of start to analyze these date stamps and look at this in whatever sort of format that we need. And so I think that's a really, I just want to point this out that with query, our goal is to be interoperating with as many different sets and types of tools as possible and being able to sort of use this in as many contexts as you like. As programmers or people who are primarily doing dev work, the place where I use query the most in my day-to-day dev stuff is whenever I'm like doing stuff that's around like golden files or trying to understand like output of something. We can use query's diff tools to sort of like deal with highly structured JSON and sort of like understand what's changing between a couple of versions. Often we'll sort of just like take our test suite's API output and just slam that into a data set and say, cool, let's just like see how that looks. We'll check it. I'll check in on it every sort of month or two, whatever, and just diff that to see, okay, how much has things changed? Not really part of our test suite, but we often do a lot of just like basic analysis of like how much data are we spitting out on our API? What's our envelope look like? It's like just a nice way to sort of analyze stuff. And then by keeping this one's native format JSON, but like I think it's worth pointing out that like this also combines very nicely with existing tools, so we can start to JQ into this like crazy and get whatever we want in terms of slicing and dicing. There are ways to get multiple bodies of data at the same time. We can chain that together. We won't go into that too much today. Cool. And so that's, I think, well, why don't we pause there for a second? Anybody have any questions on that so far?
How about the visualizations? So how do you interpret your body data?
Into the visualization?
You know which visualization
To present? Yeah. Let's check. Let's see more in section 4 on automation. I will hopefully we'll give you the proper answer. I'll revisit that in a sec.
When you did query add on the P2P,
Mm-hmm.
where was the registry?
So the registry is, okay, yes. So every query configuration defaults to registry.query.io as being the registry. You can turn that off. You can say, I want to go hard mode. I want to go fully decentralized, and I don't want to submit to any registry. The registry will behave differently in relation to you, but just the registry. That means that when you try to do query adds, you now need to be running Query Connect, and it will pull it from the DWeb instead. We find that in the office, the DWeb often wins, mainly because we have 5 computers that are all constantly running nodes, and they tend to fetch from each other faster than we can actually. We basically just put the registry and the DWeb into a race every time you run query add. And so it's like really fun to see when something wins. But if the data set is inside of our office, it almost always beats it from HTTP, which is like a fun, yeah.
So without a registry, how do you share or refer to a dynamic data set? Like
How do you deal with the dynamic nature of stuff?
Yeah.
So the query protocol actually has a way of syncing to head. So you can fetch a reference over a libp2p request. And so under the hood, query will handle that for you. So if I'm running Query Connect and I run query add and the registry is down or off, it will go do it'll send a message out to any query peer that's connected to, and that will sort of bounce around. And as soon as somebody has the latest, you'll get a couple of messages about latest, and then query will make a decision about what the smartest offer of latest was. If the peer with the peer ID that matches the thing you're looking for gives you an answer, then it's considered authoritative. And so there's like a whole conversation there.
So the reference is basically based on the peer ID. So is there any way of adding a layer of access control? Like if I want a certain peer to be able to write into that data set?
So want to get to that. If you want to work on that RFC with us, I would be delighted. That's private data and access, well, encrypted data and access control are our goals for the end of the year. Being able to say, hey, this is a data set, it's encrypted, I only want this person to be able to read the body, this person can edit the meta. That's very much on our roadmap, if that answers your question. But sadly, not right now. And right now is the only thing I care about. So, yeah, does that help?
Yeah.
Cool. Yeah. So, yeah. Oh, sorry.
No, I was just wondering, do you have any plans to try like incorporating logic into what's like stored in the Merkle DAG?
Logic into what's stored in the Merkle DAG.
So like, as an example, if there's a table that's generated knowing like what were the conditions or like the ways in which that data was generated, because like hourly can mean slightly different things if they were using aggregating.
Totally.
C versus
Totally. Yeah. So the schema design for query is based on JSON schema, which supports something called collection annotation. And so that is often where we do the majority of our data dictionary annotation work. That's obviously meant for humans. That's not a semantic mapping or an ontological mapping, which I think you're referring to. Basically, if I had two data sets and this one was in per capita and this one was individuals, can query just automatically know to multiply that by 1,000? Is that what you're asking?
No, it's more like, so imagine you have like a pipeline of data sets,
Mhm.
and like this is the raw data set, and then I have a cleaning step, and then I have some transformation logic, and the last step is the one that's like stored on the web. Or, like,
Am I paying you? Because maybe I can answer that question right now. Yeah. So let's talk about automation. All right. This is actually the next, what I think is our magic sauce. So we've embedded a programming syntax into query, which is a Python-like Turing incomplete sandbox language that allows you to automate going from one version of a data set to another. Am I close?
ish.
Cool. We'll
You
see.
keep going.
Thank you.
Like, yeah.
I'm looking forward to the improvements of this. So today we're going to do something really, really drop dead simple. We are going to ideally answer Johnny Crunch's question and get close-ish at the same time. So I'm going to make a new file, and this is going to be called download.star. So .star stands for Starlark. Starlark, just for a bit of history, came from Google's Bazel build system. This is what they use to automate builds. Intentionally, they wanted it to be Turing incomplete, and everybody inside of Google really liked Python. Data scientists really like Python. We get a lot of questions, why no WebAssembly? Data science is why. But so what we have here is a function that will, or a script that will be called when we go to save this data set. And there are two magic functions that when you define them, query knows to call them for you. The first one is called download, and the second one is called transform. In download, you get something called a context, which if you want to pass configuration to the transformation or API secrets, you can pass secrets here. But most importantly, you are not actually passed the data set, which is this DS. The data set is the thing that you edit to make differences. You can blend manual and automated transformations in the same commit. Query makes sure that those wires don't ever cross. As a concrete example, you can make a commit that updates the metadata of something manually, but uses a script to change the body. And we find this really helpful for when you get into sort of like doing deep cleaning work, it's really nice to we have these YAML files that line up, okay, this is my commit message, I'm very ready to do this, I'm gonna set this metadata, and then I'm gonna run a bunch of code. And so in this case, we're doing something very, very simple. We're going to construct an example mainly to show the automation side of this. This is going to be an example that just checks the latest version of JS IPFS. It's going to be a data set that just says, we're going to go ping the GitHub API and ask for its releases. We're going to get the JSON of that response, and then we're going to take the first thing in that response. We're going to pray that JS IPFS has at least one release. Otherwise, this code is going to break. But I think we're going to be OK. The next thing we're going to do is when that function returns, it's placed in a special place. Download is always called before transform, and download is the result of the download function, whatever you return, is passed into the CTX as this .download value. So you can put whatever you want. You can pass back tuples, you can pass back objects here, whatever you need to, and this will be passed in the transform step. Your HTTP access is only turned on during the download call. So you can only access the internet here. You can only access the DWeb in the download step. So you have to do all of your data collection first. And then when you're done, we flip off all of your internet access, and then we flip on your access to your local data sets. And for this, this is eventually setting us up for encrypted data so that if you are ever touching a private data set, query is automatically making sure that you can't write stuff that is just like a little bit malicious, right? Because we don't want to be doing HTTP posts in here of our data to some server, just as like a security precaution, right? We've intentionally sort of taken a slightly more strict approach than JavaScript or other sort of like sandbox environments. mainly because we don't know how this is going to work yet. We've had a number of debates internally, but so I'm going to save this as download.star, and while we're at it, I'm also going to include a visualization, mainly to answer Johnny Crunch's questions. So this is a visualization. This is literally just HTML templating. But in this case, we have a special thing here called all body entries. We intentionally put this in because you want to be careful with this. This is templating all of your dataset data into a dataset. You can iterate over this instead of doing this, which would be smarter. So you have to use, we're trusting that you're going to do this the right way, but hey, it's your own foot gun, knock yourself out. But in this case, we do template.html. I'm going to save that, and then I'm going to go over here, and then I'm going to make sure that, yeah, cool. And I'm going to do queries, save. In this case, I'm going to pass two files. I'm going to pass file download .star and file template.html. And I'm going to do me, JS, IPFS, latest release. And so now query is going to kind of snap into action and do different stuff this time. It now picked up on that transform step, or that download script, or that Starlark transform script, and called the functions for me in order. If I didn't define a download function, you wouldn't see the little wonderful satellite emoji. And if you're running on Windows, you're just going to see white X's, which is frustrating. But yeah, so it ran the transform and generated new data. If we do query get body on this data, we can see that it's actually the GitHub response. Cool. And so we can also do query connects and check this out. So again, I haven't published this, so this is only local. But if I do localhost, 5001? This thing. I thought so. Yeah, it always blows my mind. Let's try 8080. Nope. So the current version is this. Okay, cool. So now what we have, important step, we actually, inside of that, if we do query get on this one and we make the screen show up properly, oh no. Paste. So we have a tool called query use, but we're considering taking it out. But I can basically do this. I can do query use this. And then I no longer need to copy and paste. I can just do query get. It's stateful. I don't know. But as we can see here, we now have a transform embedded into this, and the script is actually saved along with it. So what we've done now is we've bound a script that teaches query how to update itself to the data set. So at any given point, I can do the hard way, and I can do query save recall TF. If I wanted to go back to transform scripts, I can do that. But I'm just going to do this, and I'm going to do me, JS, IPFS, latest release. And this is going to run it, and it's going to save. Cool, right? And so it's just rerunning everything and checking. The only reason this saved is because there's a bug that removes the visualization if you don't provide it again. This is myself. I'm just going to do this really quick. Ignore this. It's great. Okay, cool. Neat. So now query knows how to update our data set for us, which is helpful. And it also, the other thing to note here is because we've bound the script to the data set itself, that is part of the audit trail. And so if someone ever wanted to check my code and wanted to know, hey, did you multiply that column by 1,000, or did you change this by this? Did you forget, or are you dividing by some weird floating point number? That's part of the data set. And that's worth a lot to people who are doing data auditing, right? And we have a very, very, very explicit understanding of what happened. We're not going to go into it today, but query data sets can depend on other data sets, which means you can build dependency trees where you can load a data set, grab its data, combine that, produce some new thing. Query will, under the hood, record the exact versions that you ran all of that script at, and is aware of when those data sets change their history and can tell you to rerun your downstream data set. And so for people who do data science and who do aggregation of stuff, this is like a valuable thing. We have one last problem. We don't know when JS IPFS is going to come out with a new version. So we're in this situation. We could bend over backwards and like set up a webhook, and we could like get really deep into like some sort of custom solution for that problem, or we could do it the distributed way, the decentralized way. I'm going to just run it from my machine. So query has one last trick that I want to show you today, which is query update. Query update is a basically a cron daemon that is running on your machine that allows you to say, go check this for updates, rerun that transform script at some interval. And so I'm going to run this command, query update service start. So I do have to turn on the service. We do want you to, this is, now, it's important to note, we are not running IPFS in the background when this is happening. This is just a loop that is checking, hey, do we have any updates to run? No? Turn off. And that's it. So this thing eats like roughly 6 megs of memory on my machine. It is very quiet. So this is registered with your operating system. I apologize, this only works on OS X. Linux is coming like in a week. But now I can do query update service status. Cool, it's running, and this is coming back. We can configure this to be resource constrained. And so if we want to make sure that we don't blow up our own computers, we can do that. But I can now do query update schedule, me, JS, IPFS, oh god, latest version. And then I'm going to pick a periodicity. This is, you probably haven't seen this syntax like before, but this is repeat for a period of a timestamp of 1 minute. It's not the greatest. If you use the UI to do this, it's way less painful. But what? No. Query ls. Brendan's not great at remembering his own thing right now. Query update schedule. This RPT1M. Cool. And so if we now do query update list, in 2 minutes this is going to run. And so that's going to sit in the background of my machine and just hang out. The nice thing about version control systems is now we know what the current state of the world is. And so we know that JS IPFS is currently at 0.36.1. And when this runs, that transform script is going to execute. And if the value of the body is, or if the output of that data set is the same, query will not create a new version. It'll instead just record that it checked and keep the output of that terminal for me. And what that allows you to do is, I'm not going to get new stuff if there's no new stuff. And if there is new stuff, it'll capture it for me and tell me as soon as it found it. This is going to run locally on my machine and produce an immutable hash that I can distribute across wherever. So I'm calling this a fog service. We'll see if that sticks, but I think this is a fog service. I think that if all of our machines were passively doing some of this data set mining work, and we were then publishing that up, we got some foggy data. It's really good. I'm like all about it. Because my machine, I currently administer like roughly 50 data sets this way. And so like just every day I wake up, if we flip over to my Ever repo, like query update, log. And it's just like, we do similar to CI where we just append an increasing integer for every time it ran. Red for something broke, gray for no changes to save, and then green for we actually got a new version. If at any point I want to see the terminal output of this, I can just do this, query update log lam, and that is the terminal capture of what happened when that update ran. And so if the other thing you can do here is you can not just schedule query data sets themselves, which only allows you to get at Starlark transformations, you can schedule shell scripts, which allows you to integrate all kinds of other stuff. So you can say, hey, like the libp2p node count that we were seeing before, that shell script looks like this. Let's show you that for reals. Data sets, v5. My screen is much smaller than, it's harder to see here. Cool, so let's do this node count daily. Here's the shell script that does this one. And so this is actually a shell script that punches into Kubernetes. It does a port forwarding to 9090 for me so that I can see a local Prometheus instance, which allows me to then run a giant transform script that pulls data out of Prometheus, converts it to tabular form, slams it into query, and gives me the latest data. And so that just runs every day on my machine and publishes every day. And so that data, you will, oddly, there's some consequences to this. You will see moments where the update doesn't run. It's because my laptop was closed, and then and you'll get the update 6 hours off the schedule. But it works, and it runs. And because we have this shell script integration, you can do lots of really fun stuff, where in this case, we're just calling query save in here once, and then we're killing the proxy and closing out. So you can imagine all the things you can integrate here, right? Connect to your database, flip something to some sort of output, jam that into query, version it, close everything down, and you're done. If you're very good at managing your exit codes, Query can sort of give you back the right error message and tell you when something broke, when something didn't break. Yeah, and so it's that's just to show you what my update list. So this is, I'm only doing 4 things at the moment, but on our machine back at work, I've got, that list is very long. It's nice to just see stuff sort of running in the background. Any questions on that? We're clearly about to have lunch.
What do GitHub commits look like between different data sets or as you're versioning data sets? Like you change a row or delete a row or something like that?
Oh, like the diff?
Yeah.
Okay, let's get into this. Query diff is, the algorithm is done-ish. The visualization of it is terrible. But I think I can do, I think I'm still on query use on this thing. Yeah, query diff. So query diff by default compares the dataset top to what are we comparing? The most recent version to the latest, and because I'm running query use, I'm just doing the JS IPFS one in this case. So if I do query diff body, which is the command that you're running the majority of the time, nothing changed, right? And this is a very valuable thing. This is different from Unix diff. Unix diff compares lines of text and does shingling values for longest common substring on lines. Query is comparing structured data. And so if you have high dimensional data that is very intricate, we have an algorithm. I'll show you the thing because I think it's fun to look at. GitHub.com, query.io, deep diff. This is, what this allows you to do is compare in linear time things that are highly structured. And so this works really well in GeoJSON. That's the one where it just like rips. But it's nice because if your like subtrees are similar, it will show up as matching, and we'll use that to do diffing work. Where we need some work is we actually have to like get better at the actual visualization of this. It's been hard for us to get our head around the fact that if you want to, you can visualize moves, so you can actually show movement of stuff. And then we're also trying to figure out how to visualize column switches, which is like a fun bit of math. But yeah, that's on the roadmap. Hopefully that answers your question a bit. Cool. Yeah.
JSON available to do different things that those are nasty.
Why don't we do it after? Because I'm nervous. I'm not typing very well today. It's not going well. But yes, I'll totally show you that. Yeah, and so this is ideally sort of like adding up to something. Hopefully you can sort of see the long-term goal here. We've sort of made, in this case, we made the hourly node count is now going to just be available to you to operate on. We can also, I also prepped one other data set that I think is fun. B5, PDP node, is it GeoIP? Is this it? Hopefully this is right. No. Sorry, 1 second. Realis. Oh, is it there? Sorry. Oh my gosh. Query Connect. Let's just do this. Lib P2P nodes by country. Here we go. So this is testament to great open source. So this is what we can see. This is a scan of all of the publicly dialable addresses that our scraper has seen on the DHT over the last 6 months, deduplicated, so just the uniques, so we can see what we were publicly able to dial. And so this is, I can actually get you this properly on if we just do app.query.io, this should be published. Let's make sure. Cool, it is there. But if we get in here, like we can see some fun stuff. Like this visualization is hilariously weighted, like in the sense that, so we've got 9,512 unique IPs available in the US and then 5,026 in China. And it looks like nobody else is ever connecting, but if you mouse over these, like there's 700 unique IPs here and 1,200, and like visualization tuning is an art form, but clearly I'm not doing it here. Look at Australia, it's like 382 uniques, but like some of these get really fun. Like 90 from Argentina, Brazil 155. It's worth noting that this is in no way, this is where you got to know your data, right? This is in no way the total set of people who have connected to IPFS. This is only publicly dialable IP addresses. This is like very good stuff to know.
What is in Africa?
Can I have that database?
Yeah, 100%.
Great.
I owe this to you because this is, IPFS made a GeoIP B-tree thing. This was Ollie and Juan back in the day. I ran that to actually geocode these, and my contribution back is going to be to update that cache. But yeah, we totally have that in there. You can totally have this. You could run query add right now if you wanted, and this would go to your machine.
My computer wasn't dead.
Yeah, that offline problems.
Also, QR codes are actually typable. Not QR codes, sorry. CDs hashes.
Yes, yeah, if they were actually typable.
Well,
But
I guess
hey,
B5 /
yeah, that's the thing we help you with. We layer a naming system on top. But looking into this data, yeah. What?
I don't think this is critical for your goals, but I'm curious if you do want to have the ability to tune the visualizations.
100%. I think the thing we're going to do, we're realizing that HTML is just too much work, and so we're going to build in like a standard visualization library, and that I think is just got to come. So if anybody has any interest in like standard visualization libraries, again, we do everything over as RFCs, so everything on Query is RFCs. I'm going to go to this and shamelessly promote this repo. This is where we do all of the technical road mapping for Query, so you can see what we're going to do and how it's going to work, and you can see all the work that we haven't delivered yet, which is growing all the time. Yeah, we've based this off the Rust RFC system, which I'm a big fan of. What was I going to say there? Yeah, so this is geolocated. This is all basically with off-the-shelf IPFS projects. So this is using the same system that is happening inside of WebUI's geocoder, but it's been applied to the 51,000 unique addresses I could find. And yeah, it's kind of fun to see them. But a study of that over time is really interesting. We start to intersect that over time. But the point here is like, I've done this work for you. As long as you trust me, when you have an audit trail to trust me, you don't have to trust me. But if I do my job right and I annotate this data right, the munging work is done, which means you have more time for analysis, which means you have more time to publish cool shit back to this thing, right? And that's the only ask here is like, if you get a data set, give a data set. You know, it's like a nice karmic cycle. Maybe not 1-to-1. Well, I don't know. Let's go like 10-to-1 or something. But yeah. That kind of covers the gamut, but we have lots of stuff we want to improve. We're going to turn this into GitHub for data, so your pull requests are coming here. We got to figure out how we're going to make that work decentralized eventually. Hard problem, but yeah. Any major questions?
Well, I see Norway is not showing up there, so there's something wrong with your geo.
There is. The geocoding is old. Oh, have you actually been public from Norway at some point?
Yeah, I've got notes running at home now, so
Right now?
probably.
Oh, our data's inaccurate. Shot through the heart.
Well, these are just nodes that you can dial to publicly. Are you behind in that? Yeah, it's not my data. That's
Yeah. So let's look at the node count total. If we look at it's like, this is hourly? Yeah, this is hourly. So like 96,000 nodes. So there are presently more nodes connected than we have public addresses for. And so like that's a confusing, like ever. Like so this GeoIP one is 51,000 addresses from the last 6 months of looking at the network, right? And this
It's
is,
a GMT time.
pardon?
GMT time.
Yes, always. Does it? No, this relativizes it, actually. I think because it's JavaScript, this will load in my own time zone. But the data stamps themselves are stored in GMT.
So, like, you probably know about Kaggle or Kaggle, however you pronounce it.
Mhm.
They have not only like data sets, but they also have a pretty nice model, versioning model, like, repos.
Hmm.
So any information or desire to go in that direction.
Sorry, what was the name of the project?
Kaggle,
Kaggle. Oh, yeah. Sorry, I've
sorry.
accents.
I don't know how to pronounce it.
My accent, yeah, Kaggle. Yeah, I think Kaggle's delightful. I think it's centralized, and it drives me nuts.
So, I'm asking you, do you have plans to like go in that direction? Basically, like also have versioning or like peer-to-peer contributions for models, either models data analysis and
For the actual data schemas?
no, as in like you want to be able to produce value and insights from
Mhm,
the data,
mhm.
and a lot of times whatever's available is actually wrong. So
Totally.
it would be very good to
100%. That's the goal. Is like, hey, that's wrong, and I know why, and I'm an expert because.
So if you are going to work on that, like how far down the roadmap is that?
How soon do you want it to be?
Yeah.
Like now? Okay. yeah, we'll get some more people on the team and do it. But yeah, that's definitely where we want to go. The big challenge, I think, is like for us, we wanted to get our primitives right. Really, like it's taken us 3 years to build out something that functions in a distributed context that for us has the performance characteristics that we think are important. I didn't run query publish, but like publishing stuff back is relatively straightforward. What do I have here? Query ls again, sorry. Now I'm somehow somebody else. Let's publish this. So like this is our version of git push. Demoing this live is always fun. Is there? Oh, there's another node running in the background. So it doesn't pipe over things that don't work. So that pushed over, and this is now putting the data set. This is happening over HTTP because that's falling back, but we wanted everything to work consistently, and we wanted everything to, it needs to be Git and GitHub grade good. IPFS is the right primitive to do that on. IPFS doesn't eat your data. This is so fun to operate on locally. I can't tell you how much fun it is to work. So we're now doing a number of projects with this where I'll be working to combine like 13 different data sources into one aggregate, and having all of that in my local IPFS repo that is behaving snappily enough that I'm like literally just doing select across 10 data sets, piping that to JQ, and then spitting that out into some query, and then writing that back as a data set all in one command. It's just like really clean and fun and exciting to work on. And it's nice to have this like peace of mind that my data is organized and in a place that is very simple to push to people, right? We really wanted that situation where if you're in a lab environment and we're in the same room, I don't want to go, I mean, I'm preaching to the choir here, but I don't want to go me, S3, you. I want to go me, you, right? And that's what we have, which I think is very nice. Now we got to get to the social side of things. Like, I think the thing that we need the most work on is UX, and trying to understand how to start tackling the pull requesty, issue filing style features of this. But it's where I'd like to go.
How would you like community members to push that, what was it, RFC?
Yeah. We're like really, really hoping to sort of drive this as a community-oriented project and be very use case driven. We've learned a lot talking to data scientists in different fields. We've been talking to people in the financial space, in the geospatial space, and in the environmental space. Generally, those are the biggies that we talk to. So if you have other types of data that you're working with,
Do I have other types?
right, sorry. Yeah, wrong time to ask that question. But yeah, I think that there's a massive amount of potential here, right? We've decoupled the cost of adding data to the network. You're paying with your hard drive, and I think that's a really exciting thing. Query, just to like point to some of the niceties, like if you try to push a more than 500 megabyte data set to Kaggle, Kaggle's going to be like, we don't accept this at all. If you try to push a more than 1 gig data set to query, we're going to say, we don't accept this, you should run a node, right? And that's a different statement, which means I can host whatever I want. I can host Landsat if I want to. And that's an exciting thing. And I think we'll keep it a copy on the registry. We'll still surface the metadata on app.query.io, and so someone can see the hash and get the most recent version. And then they can use your peer to sort of grab that gigs and gigs of data. So I'm excited that this exists now. I think it's fun. But yeah, I think that was kind of it, yeah.
Maybe this is an inappropriate question for this context, but
No such thing.
What's your funding?
How do we make money?
Right,
Yeah,
well,
no.
I'm just like, 'cause, you know, I get very apprehensive about adopting tools if I'm not sure whether they're gonna exist, or, you know.
100%.
Yeah, and I mean, I appreciate community-driven
Yeah,
things,
but like at the end of the day, people got to be working on this.
eat.
Yeah, totally. We are a venture-backed startup.
Okay.
We're going to be around for many years. I'm not going to tell you how many because
Okay.
it's getting longer.
But
and
many
shorter.
is
Yeah, like
more than
a
one.
minimum of 4. Minimum of 4. It's actually after this week, we've had some great stuff happening, and so I'm not worried.
Yeah.
But so we're venture-backed. The way we plan, I'll tell you the way we plan to make money is. Eventually, we're going to spin up Query Cloud, where you can put your encrypted data on our servers and give us $5 a month, or something, some number. Don't quote me on the $5, but some number. And then the main place where we plan to make money is white labeling this entire thing into enterprises. And so we'll run private networks for larger companies who want all of this internally. Yeah, so that allows us to license this under the GPL and mean it. All of our sub packages are MIT. Mainly so that if others want to use it, there's no copy left preventing you from that. But yeah, we mean it. We're not going anywhere, but we do want to do this open the right way.
Yeah, very cool.
Cool. Any other questions? Thanks for, yeah.
Yeah, I'm just thinking like how the balance is between you can sort of describe like the delta between two data sets, and then the delta or just like you open two data sets and like how to figure it out.
Mm-hmm.
Like one of them is like much more diff heavy, and the
Yeah.
other one is like much more I can't compact my data heavy.
Yes. And so we can actually, this hasn't shipped yet, but we, under the hood, have, sorry, 1 second, query manifest, or is it query dag now? Hold on. It's a hidden command. We can do diffs of blocks. And so we can take two manifests and say, hey, what's the block differential and size differential between these two versions? And so we're planning to eventually give that to you as, hey, this is your deduplication factor across these versions. You should drop this version, right? That kind of thing is like very much something that we need. When you're managing large amounts of data inside of a block store, you need to know what that is. And so that's a different type of diff from the actual data, right? That's diffing the persistence layer, not the, yeah.
How does that interact with like deletes? Like if I wanna remove data from a data set, it's
Mhm.
not just the lack of data.
Yeah.
That was already there. I have
Yeah.
to like insert a delete.
Yes, which is going to wreck your whole tree, right? Because
Yeah.
every commit references the previous commit. Yeah, rebasing is the thing that we haven't like gone into yet. Particularly because we put the transform script stuff in. We had this like moment of like, oh no, we've made for a long-term nightmare when we go to rebase, because we have to figure out how do we replay transformation scripts when like potentially the source HTTP changed. And so we're like thinking about archival but for now, what we do a lot when we're managing massive amounts of data is just really manage the versions and like basically git commit amend. And like we eventually we'd like to get into a situation where we can do like a light commit where you're just keeping the hashed result and then sort of dropping the body. And then basically just doing that to the most recent commit and then adding the body to the second most recent commit and adding the body to the full. So you're always having the full data set at head, but then you're just only putting a light reference to history behind that. Thoughts in progress, RFCs.
I was wondering what sort of chunking type stuff you do with data.
Mm.
Anything fancy yet?
No, I really want to get to that. I've been talking a bunch with Peter Brown about it. I think that there's some like very exciting stuff to do there. We've played with the Raven chunker under the hood. I mean, just whatever you have. The current chunking strategy works for us as like a great starting point. We want to develop the block diffing thing first and then start tuning our chunking algorithm. I wanted to do semantic chunking for a while, and I've now been convinced not to do that this weekend. So we'll see how that goes. But I think chunking is the real next. That and like thinking about how can these schemas become some sort of IPLD thing where now data sets are aware of how they intersect and overlap are the two exciting things here. But that's a big conversation. At bare minimum, we're going to try to do set intersection of schemas. So like we know that this schema's entropy is a subset of this schema. So we can tell you, hey, we can smash this stuff together. We don't know if it's semantically meaningful. You can do that right now, but like, yeah. We want to eventually get to like joins that are natural and easy, but one thing at a time. Cool. Is that helpful? Thanks, everybody. You've really sat through a bunch.